All right, gonna go over the homework from 1.4, starting with problem number 1. Draw an example of each polygon. First is a quadrilateral, and basically you're gonna look for any polygon that has 4 sides. So here's one, 4 sides and 4 vertices. It's a quadrilateral. And then next is numbers 4 through 9. That's to classify each polygon and assume that all sides are straight. Starting with number 4, this has 1, 2, 3, 4, 5, 6, 7, 8 sides. Number 5 has 1, 2, 3, 4, 5, 6 sides. And number 6 has 4 sides, so that 8 would be an octagon. 6 would be a hexagon. 4 would be a quadrilateral. And next in numbers 7, 8, and 9. Number 7 has 1, 2, 3, 4, 5, 6. Oh, I see. Actually 7 sides, because this is like 1, and then 2, and then 3, and then 4, and then 5, and then 6, and then 7. So that's 1, 2, 3, 4, 5, 6, and 7. Okay, so that's going to be a heptagon. That has 7 sides. In 8 and 9, give one possible name for each polygon. So you can start with any vertex and then just go clockwise, or you can go counterclockwise. So let's just do F, I, V, E, R. And the next one, we'll just do F, O, U, R. Okay. And then we're going to do 12, 13, and 15. Okay. So in number 12, it says to name a pair of consecutive angles and a pair of consecutive sides in the figure at the right. So consecutive sides would be, or consecutive angles would be angle H and angle T. Consecutive sides, let's just do AC and CY. 13, draw a concave hexagon. How many diagonals does it have? So to review, concave means that, let's see here. So 1, 2, 3, 4, 5, 6. So there's 6 sides, and one of the diagonals is outside of the polygon. That's what makes it concave. So you have a concave hexagon. How many diagonals does it have? Well, diagonal is any line segment, any line that goes from a vertice to a non-adjacent vertice. So at this point, you would have 1, and you have 2. Oh, and then there's also 3 right here. So this has 3. And then this one over here has 1, 2, 3. Right? And so it turns out that actually every single one has 3 diagonals. So that would be 3 times 6, which is 18. But some of them, like for example, this diagonal here is 1, but then at this one, it also has 1. So you're going to double count them if you count all 18. So we have to divide them by 2, and then we get actually 9 diagonals total. So if I do another hexagon that's a little bit more straightforward, it might be easier to see what I'm talking about. But basically, let's go 1, 2, 3, 4, 5, 6, right? So there's 6 sides, and each side has one, or each vertex has 3 diagonals, right? But this vertex here also has 3 diagonals, but one of them was already counted, see? So if you, and then you have one here, and then you have one here, right? So when you actually end up drawing the diagonals at each vertex, you only get 9 of them, not 18. So every single one of these points should have 3 little lines, diagonals coming out of them, and a total of 9 diagonals. Okay. Next is 15. So 15 deals with basically that use information to name the triangle that is congruent to the first one. So EAR is going to be congruent to triangle TIN. Triangle TIN. You can see that because T corresponds to E with 2 dashes, and then A corresponds to I with 3 dashes, R corresponds to N with 1 dash. Okay, next is 17, and then 21 through 22. So 17 is basically think is congruent to power, and then find the measure of A, B, and C. So just let's locate, let's see here. This, you can a couple ways you could do it. I think for me, I would do it visually. And just imagine this polygon, just rotate it this direction. And when you do, this C lands on top of that 34. And then this A lands on top of that 44. And this B lands on the 58. And so you can see then that A would be 44, and B is going to be 58, and C will equal 34. Okay. The measure of angle P is 87 degrees. The measure of angle W is 165 degrees. What angles in think do you know? Well, if you recall from the book that when naming these, all of the vertices should correspond. So C should be congruent to P, and angle H should be congruent to angle O, and so on and so forth. So angle P is going to be congruent to the measure or angle T. So the measure of angle T will equal the measure of angle P, which is equal to 87 degrees. And then similarly with the W, I'll just do it over here. The measure of angle W, which is right here, is equal to the measure of angle I in the other one, which is going to be 165 degrees. So you know angle I, and you know angle T. Okay. And finally, 21 through 22. So each side of a regular dodecadon measures 7 inches. Find the perimeter. If you look it up in the table, the dodecadon is a 12-sided polygon. And since it is regular, that means all the sides are the same length. So 12 times 7 is the total distance around the polygon, which is going to be 84 inches. And then with 22, An equilateral octagon is 42. What's the length of each side? Octagon is 8 sides, so that's going to be 42 divided by 8 sides. And when you do that, you're going to get about 5.25 centimeters. And there you go. That's it.